I've started the recording as well as live streaming. So this session is about Kubernetes. We'll be deep diving into the architecture, and also we will be covering how it works. Just give me a minute. I'm just double checking the recording and the streaming. Okay, sure. So now I see recording, everything looks fine. So yes, we should be able to begin now. Kubernetes. Okay. So let's begin this session. So basically, we'll be covering about Kubernetes architecture. We'll be covering various components of Kubernetes. I'll give details about each of these components. So as you know, now Kubernetes is a very popular tool which is used for managing containers. So it's an open source platform. It is used for managing containerized application. Nowadays, almost all the applications are containerized applications. Everything which is nowadays modern software development practices, it involves using containers. And for infrastructure management or for virtualization, containerization is an important tool or utility, and it provides a lot of flexibility in running any application. So Kubernetes has emerged as a de facto standard for orchestrating containers. I'll cover about basics of virtualization. I will also cover about what is cloud native app, and we'll be covering also about how Kubernetes helps in running any application in a very highly scalable manner, reliable manner, and also it provides ease of development, deployment, and management of applications. So we'll also look into the Kubernetes platform, and then we will look into the benefits of platform. So after this session, you will understand the basics of Kubernetes architecture. You will also understand the critical components which are involved in Kubernetes, and you will also learn about how to operate Kubernetes and little bit fundamental commands. So let's talk about how is Kubernetes project maintained. So Kubernetes project was started by Google. Later, it was donated to Cloud Native Computing Foundation. It's also popularly known as CNCF. So CNCF also takes care of Linux projects, and it enables open source development, and it ensures that proper participation of industries and experts is happening smoothly for Kubernetes development. So this I already covered. What is the need for Kubernetes? Containerization is now very popular. Now, in containerization, the de facto standard is Docker. So when we will be covering about Kubernetes today and in later sections, we will be focusing on managing Docker containers. And we will also learn about how Kubernetes helps developers, and DevOps teams to provide automatic deployment, scaling, and management of containerized application. So the focus of the sessions will be towards developers or DevOps specialist, anyone who is a system administrator or who is an IT manager or a software architect or a cloud architect or cloud expert can also benefit from my sessions. So before I get into more details, I will also share, I have planned to cover various topics of Kubernetes. I will be covering in depth various topics of Kubernetes, and almost every Saturday, I'll be having a webinar on one topic of or the other related to Kubernetes. So watch out for the page which I shared, which is for the webinar. This page will also contain list of future webinars. Feel free to interact with help of chat, with the help of, you can raise hand. So feel free to ask questions, but I will also pause and I'll give you opportunity to ask questions. So let me talk about first, if people are wondering about what is a virtual machine. So basically, I'll start that legacy applications started on physical server. So in the earlier days, everything used to be on physical server. For example, mainframes were the right now most legacy applications which are running, and there you always use physical server to host any application. So big banks or financial institutes, when they operate their applications, they have to procure costly hardware, for example, mainframe computers, and then the applications running on mainframe application. So this is the most, I would say, the traditional approach of running any application. In this, the problem is there is expense, cost, and you don't have proper utilization of the hardware resources. For example, if you are running a payroll application may be required only once in a month. Maybe it is running on the last day of the month to process the payroll of all the employees, but still you will need the hardware to be there for the entire month. So this way you cannot use the same server for other applications because you will have a setup of application on a server. And if you run multiple applications, it may not be possible because there could be conflict between the environments and libraries and dependencies which are used for various applications. So in production application, you cannot risk having any interference or conflicts between multiple applications. So you will have dedicated resources, but this will mean your resources are not utilized properly. So next step was virtualization. With virtualization, what was possible was you were able to create multiple virtual machines on a same physical hardware. So in cloud environment, for example, Amazon EC2 instance, when you create a new instance, or whether in Google Compute or Google Cloud Platform, when you choose a compute engine, what you are doing is you are creating or you are getting a virtual machine. So in cloud environment, virtual machines are the fundamental building block. So virtual machine is something which is there, and it's only possible with the help of virtualization. So without virtualization, you cannot run cloud applications. So this is an important point to understand. Now, virtual machines are, as I said, it's a simulation of physical hardware. It's not the real physical machine. In a same physical machine, you can have multiple emulation of hardware resources. So this allows you to have separation and isolation of applications environment. And with the help of virtual machines, you are able to run multiple applications on the same piece of hardware. So when you create a EC2 instance, you don't get a dedicated physical server. You may be sharing this physical server with many other people, but what you get is you get a dedicated virtual machine. So you get an emulation of a virtual machine. So maybe in hardware, there could be a very powerful computer, but if you are asking for a basic instance, then there is a logical partition of hardware resources created for you. And with this is what you get access to. So in Azure or in AWS or in GCP, every resource is based on a virtual machine or a virtual server because it is a portion of physical server. Now, these cloud platforms definitely have to be cost effective. That's why they use virtual machines. Now, coming to what is a virtual machine, how it's powered, virtual for any resource, whether it's a physical server, what you need is you need infrastructure, which comprises of CPU and your hard disk storage and memory, RAM, and definitely network. So you'll have network cards. These are various resources of your infrastructure or a physical server which you can share across. And all these resources are managed by operating system. And in physical machine, the operating system will always be same. It will be one operating system. It could be Windows, Linux, Mac. Now, on these operating systems, you will be running your applications and you will be installing dependencies and libraries. So this is all about physical machine. Now, when we come to virtual machine, we get another layer, which is called hypervisors. Hypervisor is a software which enables virtualization. So on hypervisor, we have uh, basically hypervisor is a layer. It's a system software which allows creating of virtual machines. And virtual machines are something which is a logical separation, and virtual machines will have their own operating systems. So let me clarify this with the help of a diagram. So I'm opening a diagram, just a minute. Okay, so quickly showing the diagram. Yes. So yeah, as you can see here, a virtual machine will have at the lowest level the hardware. Then you have an operating system. Then you have a hypervisor. And then hypervisor can create multiple virtual machines. So on a same physical server, you may have multiple virtual machines. And every virtual machine will have a operating system. So here, since we have two operating systems, one we will be calling guest operating system. The other one, which is the host operating system, is the operating system which is running on the server. But in any server, you can run multiple operating systems with the help of virtual machines. So many of you would have run in your college days or in previous projects, Linux on Windows, or you might have run Windows or MacBook. All these are possible using virtual machine. So this is about virtual machines. Now, virtual machine, before we get into details of the details of Kubernetes, you should also understand what are containers. Containers are very similar to virtual machines, but they are lightweight virtual machines. Some of the examples of virtual machines are VMware. VMware is one of the leader in virtual machine. And now VMware is part of, recently got acquired by Broadcom. So VMware has a lot of softwares which is for running virtual machines. So important virtual machine or virtualization environment. So VMware has hypervisors. These are commercial applications for which you have to pay and you have to you have to get the license. And once you get the license, you can run on physical machine, the hypervisor. And with the help of hypervisor, you can create virtual machines. So two important softwares, VMware has VMware ESXi and VMware Workstation Pro. So which we see here, VMware Workstation Pro. This is a good desktop. And then you have from Microsoft also, you have a hypervisor, which is called Hyper-V. And then there is one more hypervisor from Oracle, which is VirtualBox. So if you want to try out, I'll not be doing a demo of VirtualBox or virtualization because our focus will be on managing containers. But definitely I'll give you some inputs about how to try out VirtualBox. It's very interesting to try out VirtualBox and run various applications on your machines. You may run Linux on your Windows machine very easily with the help of VirtualBox. So VirtualBox is an open source product, no licensing. It's available free of cost. You can download VirtualBox from this site, which is virtualbox.org. It will be big download. It could be around 500 MB or more. And then once you download this VirtualBox, what you need is you need an image for running various virtual machines. So this is a VirtualBox application. Download is available free of cost. And once you download, you can run the installer. Very easy to use installer. You can run it and it will provide you step-by-step instruction of installing VirtualBox. And once VirtualBox is installed, next step is to get the pre-built virtual machines. Right? You can select base images or operating systems. So it also provides some base images. And then you can build your own virtual machine if you have some requirement which is different from what is available. But if you want some application development using Oracle, then Oracle provides set of virtual machines. So yeah, here in this website, the link is there in the VirtualBox website itself. You will get some virtual machines. For example, this is database app development virtual machine. If you run this virtual machine, you will get Oracle Linux. You will get an Oracle database as well. And you can do application development using Oracle database, right? So it also provides other images where you have big data. For big data development, they have virtual machines. They have virtual machines for Solaric administrators. So most of the Oracle products you will find in this particular website. So if you are interested, someone interested in Java EE development, backend development, then this is the virtual machine. It provides WebLogic server and it provides Fusion middleware web tier server. This is a middleware. It's kind of an API gateway and message broker. So this is Oracle Fusion middleware, and then you have Portal and a lot of other components for backend development. So this is all about virtualization. Now with virtualization, we will have one problem that you have to take care of the operating system. So the problem with virtual machines are you have to install the operating system. You have to install antivirus. So that means you have to take care of the operating system. You have to apply security patches. You will have to do maintenance of the operating system as well, because you may need to reboot, apply security patches and updates on regular basis. So there is double administration. One is the administration of the host machine, host operating system. Another one is the maintenance of guest operating system, whatever you will install. And also when you reboot or restart a virtual machine, it will take minutes and definitely more than 10 seconds or around 20 to 30 seconds, because the entire operating system will be booting. So the scalability is limited because you cannot quickly scale things in and out, because whenever you will create a new virtual machine, it may take minutes or definitely tens of seconds. But with the help of containerization, I'll show what is containerization. Containerization is kind of a lightweight virtual machine. And in this, what you get, I am showing the architecture now, very similar to virtual machine architecture, but there are slight differences. One is, you see here, this is architecture of a container. You have the infrastructure, the same CPU, storage, RAM, and network resources. Then you have host operating system, which is also same. You will need an operating system to be running on any server. And then instead of a hypervisor, in case of virtual machine, we had VirtualBox or VMware software. But here you will have a Docker engine. So if you are running Docker container, you may be installing Docker engine. I will share you instructions to run and install Docker. And I will also show you various playground environments where you can very quickly run Docker also. Right? So just understand that Docker is a container engine, which is a software. It's again a system software, which is used for managing containers on any system. So here, with help of Docker engine, you will be able to run various containers. And how to run containers, I will demonstrate in detail. And then in a container, you will have libraries and application. You do not have an operating system here. So in container, you see there is no guest operating system. So that's why containers are very easily scalable. They are kind of lightweight virtual machines. So this is all about containers. So please note down the difference. What is a container? What is a virtual machine? Right. Now, next important thing which I wanted to discuss is, yes, how to install Docker or Docker engine. So let me come to that. So there is a website which is docker.com. Docker is the organization which contains which provides the Docker engine. Docker, right? So you go to docker.com. Again, if you are running on Windows or Mac, you will get the installer. Depending on your operating system, whether you are on Apple chip or Intel chip, nowadays all new MacBooks are coming with Apple chipset. So this is the first option which will be useful for Mac Otherwise, if you have an older MacBook, you may use Intel chipset. But it's important to choose the appropriate architecture, whether Intel or Apple, depending on what hardware you have. You can also run it on Windows and Linux, right? So whatever is your operating system, you can install. Again, you will get an installer, and then after few minutes, installer will complete the installation, and it's an installation wizard. You will be provided with step-by-step instruction, and then you will get a Docker desktop application, which will be very easy application to manage containers which are running on your system. So this is one way to test out Docker. Now, the latest way of testing out Docker, which is my one of the favorite, is I use GitHub code spaces. So the way you do this is, let me log in first to the GitHub so that I can show you how to use Docker without installing it on your system. This is via GitHub code spaces. So just give me a minute. I'm signing in to GitHub. Okay, great. I saw the chat message from Shrikant. Uh, you run Ubuntu using VirtualBox? Absolutely. Yes, you can run Ubuntu very easily. So nice to know you are already familiar with VirtualBox. So now let me share about Docker. Okay, so I'm logged into GitHub. So you can go to github.com. So I would recommend everyone to have an account in GitHub. So first step, what you should have is install GitHub. Just let me close this presentation for the time being. Yes, right. So that I can show you GitHub. Yes. So just a minute, let me log in. So yes. Right. So you can go to GitHub. GitHub, when you will go, you should have a profile page. So you can go to your profile page, and then you can choose a repository. So here either you can create a new repository. What I'm asking you to do is use new code space, right? So when you click on new code space, there's a new feature which is available in GitHub. You may create a repository here. I have already created a dummy repository, which is called project, right? So this is in my user account. So, okay, you can choose any repository. Say, for example, I pick any repository. Whatever I would advise, create a new repository for playing around with the Docker. So if someone is not familiar, let me help you out creating a new repository. It's very easy. say I call this learn Docker. This is my repository. I can just put some description to play with Docker, right? Uh, so I will keep this public. You may choose to create private. Also, this repository does not matter. Public repository will be shared with everyone. You can add a README file. Good practice to have a README file added and put some git ignore file as well. So if I'm working on Java, I'll choose Java as a git ignore file. This is something which will ignore some unnecessary files to be committed in the repository. You can choose the license for any project in a repository. My favorite is the MIT license, but yes, depending on your project or your preference, you may choose any of the open source license, but I prefer using MIT license. And then simply you create this repository by clicking on the create repository button. Right? So you got this repository. Whatever we will be playing around, let's keep it in this particular repository. I also share this repository link with everyone so that now you can all access this and see my exercises. So yes, in all the sessions, let's use for Docker related work, this particular repository. So let me post this repository in the chat to everyone so that you all get link to this. Right. So now I have this repository. So now next step is I can create a new code space. So this is one of the way I try out Docker without running any Docker engine on my local environment. Now I choose this repository, which was learn Docker, right? So this is the repository which we created, and I can create a new virtual machine for myself. So here I can choose a 2-core machine or a 4-core machine. I'll choose 2-core machine because this is sufficient. For Kubernetes, you need at least 2-core machine. But yes, see here, minimum which is available is a 2-core CPU. So I choose the smaller one. You may choose whatever you like, but yes, I would recommend try with the lower hardware resource because that way you will get lot of you will get less cost. But yes, this code space is you get around, I believe, 25 hours every month free. So this is which is sometimes good enough. I'm not sure 100% whether it's 25 hours or 15 hours, but it's a good amount of hours you get for free. Now, when I create, you see here, you get a complete Visual Studio running on your browser. So you got a Visual Studio and then you get a Linux operating system also. System, you get a virtual machine with Linux running here. Now, first command which you should try, say Docker version. This will tell you whether Docker is installed, and if it is installed, what version of Docker is installed here. So when I run it, you see here, it says Docker version 24.0.7.1. So basically what you get in this environment is, see here, you are seeing the message, welcome to Code Spaces. This includes Python, it includes Node.js, it includes Docker. So this is all about what you get in this code space, right? So for the time being, I'll just pause here. This is one way of learning Docker. But yes, people who prefer to run it on their local machines, they can do it in your local machines as well by going to docker.com and installing it. Right. So these are two options. There's a third option also, but that's less convenient because you don't get a Visual Studio here. So I like this option because you get Visual Studio. And if I want to create a Docker image, what I can do is I can create a new file and I can say Docker file. And you see here, the Docker icon is available here. And when I create Docker, I can install the Docker extension here, which is available in Visual Studio, and I will get the syntax highlighting, etc. Right? So you see here, it within few seconds, as I was working on Docker file, automatically Visual Studio Code recommended me to install Docker extension. And in few seconds, when I clicked install, it installed the Docker extension also. So now I will get the syntax highlighting. So when I'll be creating some Docker file, say for example, first statement which we generally use in a Docker file is we select the base image. So which is mostly Alpine Linux. If you are working on some basic environment, or if you are working on, say, on some Java project, I'll choose OpenJDK. So basically this, you get C autocomplete, you get description about the command. So it's very convenient. Now coming to the third way to try out Docker is, you can go to the site. It says playwithdocker.com. Right? So this is very good site, Play with Docker. This is done by Docker itself. So this is the official tutorial site for learning Docker. Here you can log into the Docker, and when you log in, you can log in either via Google, either via GitHub. Various options are there. So yes, here you can now again get a virtual machine. Another important thing is you should create an account in Docker Hub. So I will share you the site Docker Hub. This is required to access this site, which is playwithdocker.com. So this site is called labs.play. I'm putting again the link in the chat. So this is Docker Playground. So for getting access to the Docker Playground, important thing is you should have Docker Hub. So you should have a user sign created in Docker Hub. So create a user in Docker Hub is what I will also recommend everyone, because we will be using Docker extensively. And first requirement for running a container using Kubernetes is that your container should be registered to a Docker registry. Now, what is Docker registry? We'll learn later. But for now, you should think that Docker Hub is like GitHub. In GitHub, you will keep the source code, and in Docker Hub, you will register or keep the Docker images. Right? So if you have a user in Docker Hub, it's very simple. You just sign in, and then you will get a user. Sign up and get a user, and then you log in, and then once you are logged in, you will get access to Play with Docker. You can click on Start, and this will start a virtual machine for you. So basically now I see that, okay, for 4 hours, I got an instance for me. Now this is free for you, but only thing is whatever you will be doing, you have to save the files which you have created every 4 hours, because after 4 hours, the session will be closed automatically for you. So you'll see this timer. So you can create a new instance. And what you get here is another Linux machine, a virtual machine, but you get only command line terminal here. So if I have to create a Docker file, I can use VI editor. I can use various Linux commands and play with Docker as well. Right? So see here, this is a virtual machine, or basically they give you a container, and this is a web UI, which gives you an interface to connect to that virtual machine or container. And if you see here, this is the image is DIND. DIND stands for Docker in Docker, Docker inside Docker. So basically what you get is you get a container. So this is a container running, and this also has Docker installed by default. Right, so Docker, and then if you give the version command, you will see the version of Docker which is there. So you see here, uh, running Docker and playing around and learning Docker is very easy. There are various options, very convenient. Within few seconds, you can get a machine to play around and learn Docker. Now let's come to the file where we will be creating a container, and we will be running and registering this container in the Docker Hub. So that we will learn today. Quickly, I'll take you with that. But then I will also take you to some other information with Docker, which will get you started for Kubernetes. So let me show you the architecture of Docker first before we dive into architecture of Kubernetes, because I have presentations for architecture of Kubernetes. But before that, we should have good understanding of architecture of Docker, because then only you will understand Kubernetes architecture. So I will quickly bring the architecture of Kubernetes or Docker first before we dive into Kubernetes. So this is the architecture of Docker. It's very simple. So here you see there is a Docker client. This could be Docker desktop as well. Docker client is an interface through which you will connect to the Docker engine. And within Docker engine, what do you have is you have a Docker daemon running. Docker daemon is a background service, which is basically which is a service for managing containers. Now, when you create an image will be available in your local machine. Image is kind of a blueprint for containers. So you can think of Docker images as class, and containers are the objects of the classes. So basically, image is a blueprint for the container. Now, next thing is when you create an image, you can register the image or store the image in Docker registry so that it can later be retrieved. And you can use it, share it. Like I'm sharing code with you using GitHub. In the same way, we can also share the Docker images with anyone using Docker registry. So this is about the architecture of Docker. So now I come to Docker Hub, because Docker Hub is the default Docker registry. Now, if I say I want to do development of any platform, Docker Hub has various images available for you. So with Docker, you get the flexibility. Nowadays, I don't install anything on my laptop. Only thing which I use in my laptop is browser and the basic utilities, which may be for I various applications which I use is mostly related to editing, editor, word editor, or PowerPoint creators. So you don't need to have any development environment nowadays on your local laptops. You can always use cloud. because few months back I was planning to buy a new laptop. I was planning to buy a new MacBook, and for MacBook you will spend around 2 lakhs at least, or even if you go with the lower end MacBook, you will spend around 1.5 lakhs. But yes, I was able to save all this cost because now it's available in the cloud. So I'm using my 2020 MacBook for all this development. The only problem with this is it has 8 GB RAM. And but yes, for smoother development, I would recommend using 16 GB RAM. Either you buy a MacBook worth 2 lakhs rupees, or you can use all these tools which I'm showing. For example, code space. And even if you over exceed the quota which is allocated to you, you will not be spending 2 lakhs rupees in 2 or 3 years. Because when you purchase a laptop will only last for 2 3 years only. After that, it will become outdated and you would look out for a new device. But yes, with cloud subscriptions, it is even cheaper. You will not utilize 2 lakh rupees of your credit for running all these softwares. So was one good money saving advice. But yes, now coming back to Docker. Say, assume you want to do some Java development. So you can search for Java here, right? So in Docker, you have instances for all software. So you see here, you have Node, you have Tomcat. Yeah, because Node is JavaScript, so that's why it appeared. But I'm anyway not interested in this. Tomcat is good for running servlets and JSP technologies. So you see here, you have so many databases and Java applications as well. So there is an image for Java development also. So here, this is deprecated. So the new one is OpenJDK. So it's saying that, okay, choose this OpenJDK image. This is more uh, maintained and recent. This is deprecated. So definitely, if you go to OpenJDK, right, this is the image which is there. So if anyone is looking to develop Java applications, again, he need not have to install JDK on the local laptop. So now next plan is I will think about removing JDK from my laptop. This way I will save memory also in my laptop, because nowadays we use a lot of images and videos which we store in a local memory. So memory gets over, our hard disk fills up very fast. So using Docker saves your memory as well. So here, this is OpenJDK image. So in this, you will get all details about the image as well. You will also get details about how to use this image. So what they say, if you want to use this image, this is the Docker file. You can create some Docker file which is similar to this. So let's quickly try out creating a container and creating a simple Java application, right? So I'll just copy this Docker file. Okay, now coming back to our code spaces. So you see here, I'm back in my code spaces, which gives you Visual Studio IDE. So I'll paste this, right? So what does it says? It says you have a Docker image, which is created from OpenJDK, and that's JDK version it's showing is 11. Nowadays, it's 21, which is released. So I'll choose the latest one, right? So I'll change this. Then saying that, okay, next thing is you can run some commands. Right? So let me demonstrate first very simple operations. I may have this, and then I may have a CMD command. This is to run any command. And within quotes, I can say hello world, something like this I can give, right, in my Docker. So what does it mean is it creates a machine which will have OpenJDK, and then you can run some command which is hello world, echo hello world, right? So I believe, so if I do any mistake here, as I said, that there will be, uh, it will report to me that this is the error, right? So let me, so far looks good. I think, yeah, you can use this syntax to create a Docker image, right? So this is my Docker file, and which is in the root directory. So when I do ls, I see here Docker file is there, which is this file. So if I have to create a file, I will say Docker build. I will say build in the current directory. I may give a name to this Docker image. So let me give my Docker name hello world image, right? So this is the command which is used to build a Docker image. Okay. So Docker build first, and then I give the name, and then, yeah, I just have to give the directory in which I have the Docker file, in this case, current directory. So I use dot. Now, when I run this, it will start building the image, right? So it gives me the Docker image. So let's say, yeah. So now the image is built, right? So you see here, this image is very lightweight. It may be less than few hundred MBs. So it may be around less than 300 MBs because it has the Java. So definitely it will have. Yes, so its actual size is, you see here, this is how much content it downloaded. It downloaded 188 MB. So this command, what it does, from command, it downloads OpenJDK image, and then it also build this command, because this is the command which will be executing when I will be running this container. But yes, here you don't do any Java coding. This is just for the demonstration purpose. Now, once I have the Docker image created, I can check this by running Docker image ls. This is the command. So you see here, my hello world image is available, right? And it is using the latest version. And this is, entire size is 470 MB. Now to run this, I'll say Docker run and name of my image, which is hello world image. So when I run this command, what I get is, see, hello world printed, which is what I run here. Great. So this is all about Docker. But yes, this was very simple hello world, but we'll do something more complicated than this. So we'll write a Java code, because assume we want to do some Java programming. So the way we do is we create our Java file. So let's say this is my Java program. For simplicity reason, I'll just create a public class, and should be of the same name as my class name. So main, and then I will say, I'll say public static void main. I'll just have a main method. Let's say it contains some simple code. Right. So assume you are doing any Java development, but then Yes, let's say this is a simple program which just prints hello Java. So now with code spaces, I can just create the file, and you see here Java syntax highlighting is also available for me. And not only this, I can run it directly here. But yes, to run this, you will need JDK, right? So to do this, yes, see, I created a Java. It's automatically suggesting that you please install Java extension pack. I click here, and then it will install the Java extension pack. And once I have the Java extension pack installed, I'll be able to run this Java application in code spaces. So code space is also very convenient way to run Java programs. But even convenient is having Docker, uh, the image of your entire environment created as a Docker image and registered with Docker Hub. So now I should get the execute button. Run and debug button is available. So I can click run and debug, right? So now it's running my Java code. And in the output, I should get hello Java printed. So you see here, it compiled, it created, hello Java is printed here. So this is how I will run a Java program in code space. But this is not interesting to us. Our interesting part will be how to create an image and run this code inside the Docker container, right? So we'll do that. So this is what the code is, which says this part, right? I'll explain this part and show you. So I'll go again to the Docker file. I will say copy, and then I will put that copy the current directory to this folder in the Docker file and make this folder as the working directory for Docker file. And then run Java compiler and compile main.java, because yes, currently now in the current directory, I have main file, main.java, right? So this command is valid. And then finally, you will execute the Java main command to execute this Java code, right? So let me now rerun the Docker build, because now I have modified the Docker file. So I'll go here. I'll say Docker build. This time I'll name my image as my Java image, right? And then I will say name of the Docker file and name of the directory which contains the Docker file. Against building the image, and in few seconds, it took, yeah, maybe around 6 seconds to build this image. Now, once I have the image, I will check whether this image is there or not. So yes, it will be. So I see here, my Java image is available here. So now I will give command docker run my Java image, and this will print hello Java. Basically what it's doing, it's running the code, and in the code we have this instruction. So it's running the Java program which we created. So this is how you can run your Java code inside Docker. Now, next thing is how to register this image, how to share this image in multiple environments. Because yes, you may close this code space, or you may want to run this in your local Docker container or in some other container. So now what I will do is I'll show you how to share the image in the Docker registry. So this part is important because after this, we will be able to run this with Kubernetes as well. So I run the command Docker, and then I will say push, right? But in order to use Docker registry, the first thing is I need to log into the Docker hub. So I run this command Docker login. You see here, login is succeeded, but I didn't give the password. So here there is some catch. There is some configuration file, default configuration file. So basically the command to store will require your credentials. So let me just go to this file. This file is within the home directory. So this is, I'm saying cd home code space docker config.json. Okay, last part is not the directory. I should do yes. Docker. Now let me open this file. It has some token. All this I'll remove because this is not what I have configured. This is coming by default in code spaces. So I remove this part. See, note down, this is an important step because without this, you'll not be able to register the images. So this is GitHub credentials, but yes, it will not have access to our Docker hub. So I'm just removing all this part. I'm still to figure out what these credentials are used for. I'll let you know in coming classes. But yes, we need to remove this. This may be probably used in GitHub Actions or some other internal tool within this code spaces. But we don't have to worry about this so right now. So I'm just removing everything and then I'm again giving Docker login command. Right now, see he's asking for username and my password. So I give my password and I should be logged into Docker Hub. Now I am logged into Docker Hub. So login succeeded. So Docker push is the command which we'll be executing. But before that, we'll name this because since I will be sharing it, this is better to follow some convention. So I'll say Docker -t, then I will give the name of my, I'll rename this image, right? So what I will say is I'll rename this my Java image. Now why I'm renaming it, I'll also tell you, but just hold on for a minute. So yes, I'll run the command docker tag and I'll tag my Java image as my Java image. Always good practice to tag your image with your namespace containing the username. So basically first part is my Docker username. You can use your username. So you should use your username so that you remember that this is the container, because if you make any public image, it will be visible to everyone. And if someone has also already created my Java image, which is very common name, so then it will be conflict and will be difficult to figure it out if you don't give the namespace that which images you have created. So let me tag this. Now I have tagged it. So I should be able to see this image changed. So if I say Docker image ls, you see there is this tag also available. Both are pointing to the same image. So now I will say Docker push. And what I need to push is my image, which is ttelang, and then my Java image. So now the entire image which I created in my code space will be moved to Docker registry or Docker hub. So let me open Docker hub also. So hub.docker.com is the URL. Hub.docker.com. So when I go inside this, right, you see here, a minute ago, this is pushed. Ttelang, my Java image is now available here in this Docker registry. Right. So now see this image is now shared across. Now, next thing I'll do is now you would be wondering how to use this Docker image. So let's run the same code here. So if I have to run the same Java program here, see what I have to do, right? So this is my another virtual machine. I say Docker login. Yeah, definitely to pull the image, I need Docker login. I'll give my username. I'll give my password, right? This is a different virtual machine. This has nothing to do with code space. So you can do it if you have Docker installed on your local machine. Same steps you can follow. You will also be able to run the code and you will also see the output hello Java, right? Now you say Docker pull, then this is, I have to give the name of my image. So my Java image. See, now it's downloading it. It found that image and it's downloading the image to this computer. This is a pre-built image available. So here you don't have to build it again. You can just run this. So you see here Docker image ls. You'll see that image is there. Now to run the code which I kept inside this Docker image, I just say Docker run and my image name. What should happen? Here, it should print hello Java. Okay, see, the Java code is printed. And where is my Java code? I have this code inside /user/src my app, right? So within this particular, uh, within the Docker container. So that's why this was able to run it, right? So this is complete demonstration of how you create an image, how you run an image, how you push the image to Docker registry, and how you pull the image and then execute from any other machine. So I'll pause the session here itself and any questions, doubt. I think today this is one of the fundamental understanding which we have got is how to use Docker, how to use code spaces, how to use Docker playground as well. So more practical demonstrations on Kubernetes and further concepts about architecture of Kubernetes will cover in the later sessions because today we are already over time. But yes, I hope you got a very thorough understanding of Docker architecture. because Docker architecture is important, very important to learn about Kubernetes architecture. So this is Docker architecture. So we used this command Docker pull, Docker build, Docker run. All these commands we used. We used Docker registry as well. You saw what is Docker daemon, what is Docker images, and Docker containers. Right. So Docker daemon is nothing. It's the process which is running here, which is doing all the background processing of building a container, etc. Right. So if you run the ps command, so here you will see that Docker, there will be a daemon which is called Docker D, which is running. So basically, I'll do this here in the say if I run this ps command, you see here Docker D. This is Docker daemon, which is running, which is doing the background stuff. Right. So now this concludes the session for today. I will be opening up for questions. Any questions, please feel free to ask.
Tarun, thanks a lot. This was
Right.
a good session. I do not have any questions actually.
Nice,
It was
nice.
quite
No
clear.
problem.
Demo
Yes.
was good, and this code spaces was something new. I did not know about it, so it's pretty convenient to go directly use code spaces there. Yeah,
Yes, yes, absolutely. Right.
I will play
Very
around with
nice
that.
feature. Yes. So yes, we'll explore it in more detail
Yeah,
because this is just a tip of iceberg. And in coming sessions, we'll be covering more code spaces we can use with Copilot as well. And yes, Copilot is AI technology which can code for you also. So, but yes, that is another, we'll see that as side activity. But yes, our focus mainly will be on Kubernetes and how to build a complete application. I'll do a complete project where we will be running a microservices based application using Kubernetes. So that's goal. But yes, it will take multiple sessions, but slowly and gradually we'll be proceeding towards that.
great.
Awesome.
Thank
Thanks.
you for the session. Thanks for the discussion.
Yes, thanks for your feedback. Okay. Good night.
Good night, Tarun. Thank you.